Greetings! In the first tutorial, we got familiar with Zend skeleton, but didn't get a whole lot of actual work done. We just looked around. Now is the time to do something more interesting by creating our own module. Today's purpose of creating a module will be to answer an age-old question of what will go in the M, the model of the MVC. Now, why am I bringing up MVC since we're talking about modules? Well, that's because we need to create some classes, some objects, but where do they go? Do they go into one module? Do they go into a subsection of that module? Or do they go into a whole module altogether? There are 4 questions that always arise whenever we consider creating an action to do anything. When we did a walkthrough of the skeleton, we came across this part, the index action, that returns some kind of view model. This is the part where we're going to take some data and we're going to put it into our output, be it HTML or JSON. So the question there is, how do we call the class methods and get their output to view? The answer to that is clearly we need to do that in the controller, because that is the only place where we have access to both the data and the view, so we can pass the data between them. The next natural question is, where does the data come from? How are we going to create those classes? They need to be created somewhere. The general rule is if the class creation doesn't take more than 2 lines, that can stay in a controller. Beyond that, we probably want to create a special class that is used just to create other classes. We're going to call that a factory. Where is that going to go? We don't really know at this point yet, so let's move on to the next question. Given that we have some kind of general idea, how are we going to take that idea and make it useful for that specific action? For example, let's take a concept of issues assigned to a user. We can have a whole lot of them, 100. So we may want to paginate them. 10 on page 1, another 10 on page 2, another 10 on page 3. We may want to filter those issues or search them. Or the issues can come from a whole different place. For example, we can have a GitHub hook that calls the application through command line. So when we have a commit, there is a background process that takes the commit message and decides to perform some kind of action on our issue. So now we have a situation where the program is being interacted with from both the web interface, command line interface, or some other operating system process. So where the code for that would live? That code would probably live in some kind of module responsible for a web interface, so maybe web interface module, or a CLI interface module. But where do those ideas come from? What is it that the application is actually about? We can't interface with something that we don't really know what's going on. For that, we need to define proper data structures and their methods. For example, we may have a concept of a user and the ability to assign an issue to that user. We can have a concept of a workflow and the fact that we can move next in its progression. And when we move next in a workflow, we can take an issue that is assigned to a user and change their status to being in progress, or maybe to closed or reopened, all the way until workflow is fully complete. Those concepts, the things that the application is actually about, they're going to go into a special module, the entity module. This module will be responsible not just for housing the logic, the definitions of our concepts, but also their creations, connection to the database, and a data mapper that will take the data from the storage into memory and back from memory into storage. A skeleton installer took us only as far as web interface module, so now we need to go and create our entity module. Technically, entity module is not a Zend Framework specific concept, but since Zend Framework is designed for large applications, you need to have an appreciation of what it's like to create an architecture. Unless you understand the concepts of architecture, your experience with Zend Framework can be quite miserable. So we're going to lay down the architecture and organization principles as we learn specific Zend Framework components. With philosophy finally out of the way, we need to instantiate our project to be version controlled so that you can pick it up from GitHub. I'm going to do a quick git init since we actually deleted the Git repository during the last step of the skeleton installer. Initialize Git repository, and we are going to do the infamous initial commit. Up, no changes, of course, because we probably should add everything. Commit changes. Initial commit. Committing front-end sources and libraries is a bit not nice, but we will move those probably sometime when we get to the UI part of the work. Commit. And having everything done, we're going to create a new branch for our tutorial. This one is 2 modules. So now you can clearly see in a GitHub repository what code belongs to what tutorial. You can jump between branches to get yourself synchronized with what I'm doing. Now, would I get on with creating a module already? We are going to call ours ZFT for Zend Framework Tutorial. That is going to be all of our entities, the classes that the application will actually be about. I'm not overly sure what direction I want to take it in. I'm thinking some kind of issue manager, maybe similar to Jira, tie it in with email messaging so we can use it as personal email client, and something to inspire us to use it on a daily basis. ZFT is our directory, and underneath that, following the style of skeleton installer, we're going to create an SSC directory, and underneath ZFT again a file module.php. Yes, add it to repository, and this module.php file is going to take the namespace of the module name class module. Now, not all modules have to have an MVC. Remember, MVC is specifically for taking user input and moving that data from the input back and forward to the models. This is going to be explicitly entities, explicitly only what the application is about internally at a low level. So we're not going to deal with controllers or views here. But what we do need to deal with is letting it know how to find this namespace. Since Zend Framework 3, we finally do not have the Zend autoloader anymore. So that's a lot of stress out of the way that we don't have to deal with. All we need is to let the composer know how to find it. Our ZFT namespace in PHP, so this is all now PHP based, not Zend Framework specific anymore, lives in module ZFT SRC. And let's comply with JSON syntax. Having created this namespace definition, we need to kick the composer to create autoloader files for it. Otherwise, it may not always find them and complain that the classes don't exist. So composer var dump autoload. And of course, we cannot forget to add that module to a load definition. We want to do this above the application or above anything that will use that module. So Zend Framework loads modules in the order they are defined in modules.config.php. So if ZFT is going to be used in our web portal module or our CLI module, it has to be at the top of wherever it is going to be used at. Let's check the results real quick. And we're still good. We even have our ZFT module loaded according to the toolbar. I'm going to commit this because this is a nice endpoint before the next step. Added ZFT module. So if you ever want to know how the module is created, you can just look at the git diff of this particular step. Next, I would like to rename the application module into something that's a little more suitable. I'd like to have anything that is loading entity modules into the front end, into the browser, called a portal. Application is just way too generic for me. I'll go a little backwards this time. I'll rename this into portal. The browser should complain a lot. Yep, no such thing as portal, not initialized. Let's fix that. Going to slowly but steadily start by renaming the namespace. I'm going to rename that into portal. Rename the folder. Portal. Some more namespaces. Portal is now found in a portal directory, not in the application directory. How are we doing here? Yep, we're good. The IDE has helped us rename the controller namespace as well. Tests. This is now portal test. I think we should still be failing, right? Yep, we're still failing. No test executed. Why is that? That's because this is now a portal test. Zend skeleton application test suite, more like web issue portal test suite. There we go. That's a bit more suitable. We're still failing. Module could not be initialized. So you see, I now take preference of checking the changes in unit tests as opposed to refreshing the browser. This is a much better habit to get into. Unfortunately, it doesn't quite tell us why things are not initialized, but I have some ideas. And since we changed the namespace, we should redump our autoloads. So the classes can now actually be loaded. We just have some problems with the 200 versus 500. Looks like the application is not processing our requests correctly. So this is good. This is why unit tests are important. They say what has failed when we make the changes. We are told by the unit tests that we have forgotten to also rename our view folder to comply with the changes in the namespacing. It's not application anymore, it's portal. Let's check our test. We're still failing. Application action module name. And we will allow ourselves to change the unit test. Usually you don't change the unit test unless your actual specification changed. If your test fails, it's a sign that you have actually legitimately forgot to do something and the unit test is correct. But in this case, the specification did change, so we will allow ourselves to update the test. So the module name is portal. And now we're passing. And since this is passing, our website also works. Doing another commit so that whenever you need to change a module name, you can look at the diff in the commit history to see exactly how it's done. Rename application module to ZFT. With the module created, now we need to figure out what to do with it. Unfortunately, learning this part of the framework is a bit annoying because to understand the way the module works, you have to be aware of Event Manager and Service Manager because the two put together will help to create the module structure. But I can't really go into teaching Event Manager because by itself it also doesn't make sense, and Service Manager also doesn't make sense on its own. When we look at the official documentation, we're told that there are certain functions that occur during certain events. That's where the concept of Event Manager comes in. And then as we go down, we're told that the module also brings in configurations to the service listener. So that's where the service manager comes in. To figure out what is going on here, what all this means, we need to quickly look at the concept called object lifecycle. So if we just do a very simple stick drawing, let's have an object that does something useful. We're going to create it. And as it performs our tasks, it has certain life events. It obviously gets created, and at the end it gets destroyed. So that's at least 2 events that it goes through. As it executes its job, whenever it completes a subtask, we can designate that as a subtask event completion. So say it's a user object, we may have a special event when the user finishes logging in, special event when the user finishes paying their bill, that's pretty important, and when the user logs out. Each of these milestones are triggered by the system, by the user actions. And for each of these milestones, we can have functions registering to run when they happen. So whenever the user logs in, we can have some kind of listeners. We don't know what those listeners are. There's just some other little programs that are looking out for these event life cycles to occur, and whenever they notice that they have happened, they're going to run something, and they're all independent of each other, and the user object doesn't even know about them. It just shouts out, hey, I've done something, and anybody who's listening to that is going to act on it. And not all events obviously may have listeners attached to them. Some may have just one, some may have none, some may have multiple. Every system is going to have its own set of lifecycle events. The module has one, then the MVC is going to have some, View Manager is going to have completely separate its own, and you're going to create ones yourself when we get eventually to Event Manager chapter. Typically, in an event management system, you would manually register to run events. So for example, you would have object on event name run this function. However, in this particular case, that registration has already been done for us, so it may be confusing looking at this to realize where these events are coming from. So we're just going to assume that Zend Framework has already done the registration for us, and it calls a certain function names if those functions exist within the module class. Where does that say that in the documentation? Right down here by the module manager's listeners. By default, Zend Framework provides several useful module manager listeners. All shipped listeners are in a Zend module listener namespace. That is very important. Let's explore that. So let's look at what's inside of that. We'll go on Open Up Vendor, Zend Framework, Module Manager. From experience, the ones that I know are the most useful are Config Listener, On Bootstrap Listener, and Service Listener. Their description is in the manual. So Config Listener is set to all the configurations when the module is started. So that's how these configs in the config directory got into the module class. There was some kind of event that says, hey, I am now ready to accept configurations. Is there a method in the class called getConfig? And if there is one, it's going to execute it, and this method is going to return the configs if there are any. What I don't like about the default setup is that it's not quite obvious. So as we see from the manual, if we use these interfaces, it's going to be easier to figure out this is actually what's happening. So in this particular case, the config listener, the thing that gives us configurations, is available when we implement a config provider interface. So let's just do that to make it easier. Implements config provider interface. And having done that, we now have the PHP conveniently tell us that the getConfig method actually came from that interface. This helps us to structure our module class properly. So instead of trying to remember what functions correspond to what events, all we need to do is look at the listener interfaces that are available underneath namespace, implement those interfaces, and the IDE will tell us what methods Zend Framework needs to do its job. So if we forget to do the config function here, but we know that this module must supply configurations of some kind, any kind, it's going to tell us that, hey, we forgot to actually put those configurations in. Let's do this one more time for the onBootstrap listener in the portal module, because I will know for sure I'm going to need to do something on every single page load when I access the website. The documentation tells me that not only will the method be called, it's also going to be passed in an MVC event. Therefore, I know I am going to be given a route that tells me what the user is trying to do. And therefore, I can predict that this is a good place for me to check permissions to verify that what the user is asking for is really what I should be looking at, and if not, I should redirect them to a login form. That's of course only one example. You can think of anything else you may want to do at the beginning of every page load. Just make sure it's lightweight enough because it gets executed every time. Okay, so let's get on with it. I am going to implement that interface. Bootstrap listener interface. Now the IDE is telling me that I have errors. Why is that? That's because I need to implement on Bootstrap. And so this is nice because I don't have to be second guessing what it is that the function needs to look like. I can just have my tools help me to figure it out. I'm going to leave it empty for now. Just have a single return statement so I can use the magic of breakpoints to see what's happening. The debugging on and refresh the page. We know that indeed it has automatically entered this function. And we even have the event object that the documentation has promised us we're going to get that includes more details about what's happening, including the requests that the user has applied and the response they're going to get, the router telling us what the user is trying to do, and anything else interesting about the state. Another one that we need to implement for sure is the service listener. But it's a bit different and more difficult because it's not a single method, but a collection of methods. We have the getServiceConfig function, which we're told will be run if it's present for the service manager in general, but we're also told that other subsystems, other Zend Framework components, are going to be looking for their own methods. So the controllers are going to be looking for that, and if you're using views, they're going to be looking for that, and so on. The portal module is going to get their service listeners configurations in due time. For now, I am going to do that only in the ZFT module. So I want to make sure that we have access to service manager configurations so that we are ready for the next chapter. Service provider interface, and we are implementing getServiceConfig. Doesn't tell us what we need to return, does it? Oh yes, we do. We need an array for that, so return an empty array for now. Let's verify that this is actually going to work. Put a breakpoint in there. Oh, we still have an add-on going. Refresh again. So now see, it went into the ZFT module first because that is the order in which they are defined in here. This one gets run. Then this one gets run. Then there's actually another one that I know would run, which is merge interface. That's where all the modules are coming together. That may be another one you could be curious about. And the application is being brought up. As a final word, need to realize that all the configurations are merged into a single one large configuration array. So any configurations you're going to have in the ZFT, any configurations up here, or even any configurations within the individual Zend components that we don't see straight away but are hiding in the vendor directory, all of those are brought together into a single merged array and can be accessed anywhere. So any module can see any configurations from any other module. That is going to be accessed through the service manager actually, and that's going to come up next.